So, yeah, it's incredible when you think about how fast clean energy tech is evolving. Just wow.
It really is.
But all that groundbreaking stuff, it's sitting on top of this really intricate global economic system, isn't it? You've got supply chains everywhere, tariffs, energy prices bouncing around.
Yeah, it's a lot. It's complex. And to really get a handle on where we actually stand, economically speaking, with this whole decarbonization push, you need to, well, dive into the numbers.
Mm-hmm.
And that's exactly where this latest Carbonomics report comes in.
Yeah.
It's just packed with that kind of detail.
Exactly. So we've got this report, a real deep dive looking at the costs, the roadblocks for decarbonization, like right now in 2025.
Great.
And, if you're listening, you probably want to get smart on this stuff fast, but like properly understand it. Our mission here is to pull out those crucial insights for you.
Yeah.
We're talking the main cost trends, how things like deglobalization, energy prices, how they're shaking things up, but without, drowning you in data.
Think of it as your fast track, your shortcut to understanding the current economic picture. I mean, this report looks at over 100 different technologies.
100.
Yeah, across all the key emitting sectors. It's pretty comprehensive.
Okay. Let's get right into it then. What are the sort of the big picture trends? What's it costing us to go green right now?
Well, what's really interesting, actually, is you're seeing this kind of two-speed thing happen.
It's two speeds. How so?
So for the technologies that are more, let's say, mature, established, think the lower half of the curve costs are coming down significantly, about 7% cheaper than last year.
Oh, wow. Okay.
Which is fantastic progress. In fact, as you look back since 2019, just pure technological innovation has brought costs down like 45% cumulatively for that bottom half.
45% drop. So are we talking things like solar panels, wind turbines, that kind of thing getting much cheaper?
Precisely. Those are big drivers. But, and this is the other speed, when you look at the sectors where it's just harder to cut emissions,
Yeah.
maybe the tech is newer, more complex.
Right. The tricky stuff.
Exactly. There we're actually seeing costs go up. The report points out, while the cost for that first 50% of emissions reduction is down 7%, getting the next chunk up to 75%, well, that's actually become about 5% more expensive.
Huh. So that split is really key then. Good progress on the easier wins, but the tougher challenges are getting pricier.
That's a pretty fair summary, yeah. Now, if you zoom in a bit, batteries. The report really highlights batteries as a major cost down driver.
Batteries. Yeah, they seem to be everywhere now. Phones, cars, hopefully more cars. What's the impact there cost-wise?
It's substantial. I mean, cheaper batteries directly lower the cost of decarbonizing passenger transport, makes EVs, a much more viable option economically for more people. And it's also making solar power systems with battery storage much more affordable. We're talking cost reductions over 30% year over year in some cases.
30%. That's huge for making solar reliable.
It is. And the forecast, it suggests average global battery prices could even drop to around, say, $80 per kilowatt hour by 2026.
$80. Yeah, that could really, really accelerate the shift to EVs, couldn't it?
Absolutely. Could be a game changer.
So what other tech is getting, more budget-friendly?
Well, standalone solar generation, just solar on its own, that's down about 12% year over year.
Still dropping?
Yeah, solar PV, still the cheapest way to make electricity, basically. And module prices themselves have fallen, really significantly, sometimes even below what it costs to actually make them.
Wow, below production costs.
Sometimes, yeah.
Huh.
And biofuels, too. They become about 40% cheaper. That's mostly lower prices for renewable diesel, RD, and sustainable aviation fuel. SAF.
Okay, that's encouraging, especially for tricky sectors like aviation, right, where batteries aren't really an option yet.
Exactly.
But you mentioned those hard-to-abate sectors earlier. Where are we really hitting the cost challenges?
Industry. That's a prime example. Very little progress, really, in bringing down decarbonization costs there.
Why is that?
A big reason is just the lack of progress with hydrogen-dependent technologies. Things like green steel.
Right, relies heavily on cheap green hydrogen.
Precisely. And the average cost to decarbonize industry, it's actually jumped up by 25%. And that's largely driven by higher projected costs for hydrogen tech. The model now uses around $5 per kilogram.
$5 a kilo. Yeah, that still sounds like a pretty big economic hurdle for widespread use.
It is.
Any other sectors facing similar headwinds?
Heavy-duty transport is another one. Electrification costs, they're just lagging. Electric trucks, buses, still a big price premium over diesel.
Still expensive up front.
Yeah. And then buildings. If you're looking at using hydrogen boilers, the abatement costs there are going up too. Again, because of higher modeled retail prices for hydrogen, now around $8 a kilogram for that use case.
$8. So it seems like hydrogen, in some areas at least, is proving maybe more expensive, more complex than perhaps hoped.
I think that's a fair conclusion from this report's findings, yeah.
Okay, let's switch gears a bit. This whole idea of deglobalization tariffs that's been getting a lot of airtime. How's that playing into the economics of all this?
Right. And this is where it gets really interesting, like you said. The report suggests that if we see this shift, more local production, fewer global trade links, this deglobalization trend,
Yeah,
it could actually add something like 30% to the total cost of decarbonization.
30% just from supply chain shifts?
Potentially, yeah.
Yeah.
What's fascinating, though, is it's not the same for every technology. Some clean tech, like bioenergy, grid infrastructure, electrolyzers for hydrogen,
Mm-hmm.
they tend to be more locally produced anyway.
Okay.
But others, and this is key,
Cost and trade there.
transport. Overall, the average carbon abatement cost there saw a slight fall. Progress in passenger EVs and biofuels is helping,
Good.
but it's kind of offset by the higher costs still sticking around in heavy-duty transport, trucks, buses, like we mentioned.
Right.
But here's a big number. The carbon price difference between local production versus cheapest imports and transport. It's around 80%.
80%. That's enormous. Where's that massive difference coming from?
Batteries,
Mainly.
EV batteries. China just dominates manufacturing there. Now, the U.S. is really pushing to build its own supply chain, with the Inflation Reduction Act, the IRA. Could potentially hit self-sufficiency in maybe a year or two.
Really? That quickly?
Potentially, yeah. Europe, though, looks like it'll stay reliant on battery imports. Could face maybe a 20–30% shortfall in domestic supply. And for Europe, importing those LFP lithium iron phosphate batteries from China, it's just very cost-effective right now.
Gotcha. What about the biofuel side of transport?
Right. Renewable diesel, North America is the biggest producer there. The EU put those anti-dumping duties on Chinese biodiesel. And China also removed an export tax rebate on used cooking oil, which is a key ingredient.
Feedstock costs.
Exactly, impacting costs. Interestingly, the theoretical cost to produce renewable diesel is maybe $300 per ton higher in Europe than in China.
Another cost difference. And sustainable aviation fuel, SAF.
Still very new, really. Nascent industry.
Yeah.
But expected to grow fast because of mandates, especially in the EU and UK.
Okay. So transport sounds like a real mix. Tech progress, huge trade dependencies, policy shifts, all tangled together.
It really is complex.
All right, finally, let's just touch on industry and buildings and the role of green hydrogen there.
Yeah, these sectors, for really deep decarbonization, they're banking heavily on green hydrogen becoming available and affordable.
Right. It all comes back to hydrogen costs.
Pretty much. The levelized cost of hydrogen, LCOH, that's the key variable. Now, for industry, the report finds the average carbon abatement cost doesn't actually change much whether you assume local hydrogen production or importing the cheapest hydrogen.
Oh, interesting. Not much difference for industry.
Not a huge difference in that modeling, no. But for buildings, the cost is slightly lower if you assume access to cheaper imported hydrogen.
Okay. So the whole economic viability of green hydrogen, producing it, distributing it, that's still a pretty big question mark, isn't it? A potential bottleneck for those sectors.
Precisely. A major uncertainty still.
Well, this has been incredibly insightful, a really useful deep dive into this Carbonomics report. Just to quickly recap some key things for you listening.
Yeah.
We're seeing this uneven picture, right? Costs coming down for established clean tech, which is great, but going up for the harder to abate sectors.
The two-speed transition.
Exactly. And global supply chains, this whole deglobalization question, tariffs, they have a huge impact on costs. Energy prices, too, like natural gas.
Definitely.
And each big sector, power, transport, industry, buildings, they've all got their own unique economic hurdles and, well, opportunities, too.
It's really clear that, while innovation is doing amazing things driving down some costs, there are still significant roadblocks, especially in those really energy-hungry, complex sectors like heavy industry and heavy transport.
Absolutely. So here's maybe something to chew on, something to think about after this. We've talked about these trade-offs, haven't we? The kind of cost savings we get from these interconnected global supply chains versus, the potential upsides of building more local production, resilience jobs, maybe. So what's the right balance there for hitting our climate goals and having stable, strong economies? It's complicated, no easy answers. But it feels like a really crucial question as we keep moving through this energy transition.